Okay, students. So in the last video, we were discussing about, we have discussed till fourth problem. So in the fifth problem, half we have discussed. So we will detailedly discuss now again. So the fifth problem, we have a wall which is having a dimension 30 and 15 meter, and ceiling height is given. So this is not mounting height, and the mounting height has to be calculated over here, and the other data are given over here. And actually we need to calculate the mounting height and the spacing and the total wattage of each lamp we have to calculate, and the wattage of each lamp they have given in the problem itself, which is nothing but 80 watt tube. So first of all, we will list out all the data. So the list of data is given over here, and we need to calculate the gross lumens required. So the gross lumens can be calculated by this formula. If maintenance factor is known, then you have to divide by MF. If depreciation factor is known or given, then you have to write it in the numerator. Then substitute all the data, then you'll get the gross lumens required. Next, we have to calculate total wattage required. To calculate that, the efficiency is given. So therefore, it is nothing but gross lumens divided by luminous efficiency, which is nothing but 3780 watts is the total wattage. That is the overall wattage of all lamp. And the wattage of each lamp is given, which is nothing but 80 watt. So therefore, we can calculate how many number of tubes are there. So therefore, the number of tubes are required is nothing but total wattage required by wattage of each lamp. So therefore, 3780 divided by 80 will give you 47.25, which is nothing but 48 tubes. So instead of using 48 tubes, we actually increase the two lamps, which is nothing but 50 tubes, because to round off the term, and also if you increase the number of lamps, then you'll get more illumination. So for that purpose, we have increased two lamps. So therefore, let us take total lamp as 50. Then we can divide. That means if you have 50 lamp, you can divide in your way. If you have 48 tubes, so only you can divide, which is nothing but 12 into 4. That is 12 in lengthwise and 4 in height wise or width wise. So that 12 into 4 is nothing but 48. You can take that combination also, or you have the other combination, you can take that also, but the distance between the lamps should not be much distance, it should be of lesser distance. So therefore usually we will take in this way, that is in lengthwise we will accommodate as many lamps are can be adjusted, and in the widthwise we will restrict only to fewer number of lamps. So therefore as I taken 50 lamps, so I'll divide it into 10 into 5. Because if I divide in this way, then actually we can increase the number of lamps in horizontal direction, and the the increased number of lamps in vertical direction. So therefore, the 10 lamps in horizontal direction and 5 lamps in vertical direction or in width side. So next we can also calculate the axial spacing. So axial spacing can be calculated by this formula, which is nothing but total length of room divided by number of lamps, because number of lamps is already known in row side. So therefore total length is also known. Then you can actually calculate axial spacing, which is nothing but 30 by 10, which is nothing but 3 meter. Next, transfer spacing can also be calculated in this way, that is total width of the room divided by number of lamps in vertical direction, or number of rows. So therefore 15 by 5 is nothing but 3 meter is nothing but the transverse spacing. Next, we have disposition of lamp. To draw that, you have to draw this diagram. So you have to thoroughly draw this diagram. So this is actually the disposition of lamp diagram. And as I told you over here, so there are 10 lamps. You can see here 10 lamps in row direction, that is in horizontal direction. So 3, 6, and 9, 10 lamps are there, and horizontal spacing between them is 3 meter, and vertical spacing, that is axial spacing, is 3 meter, and vertical spacing or transverse spacing is again 3 meter. And as I told you here, you can see here we have covered only the horizontal spacing between the lamp, but which is less than the total length, which is 30 meter. So to calculate this, we will go in this way. That is 3 into 9, which is nothing but 27 meter. 30 minus 27 is nothing but again 3 meter. So therefore we have left out with 3 meter. So then divided by 2 will give you the value, that is distance of lamp from wall and the distance of the lamp from the wall side. So therefore it is nothing but 1.5 meter. If you add all these value, then you'll get the total value. Again, in the vertical direction also, you have no, 3 meters. So therefore 3 into 4, 12 meter. So only the lamps have covered only 12 meters. So again, we have left out with 3 meter. So which can be calculated again 3 by 2, which is nothing but 1.5 meter. And in the problem only, they have given the value that assume space to height ratio as unity. So therefore, mounting height can be calculated. What is the mounting height? It is the horizontal distance between the lamp, or you can call it as axial spacing divided by space to height ratio. Axial spacing is given, which is known actually, and it is 3 meter. Space to height ratio is 1 meter, which will give you the value 3 meter. So like this, you can calculate the value. Next, we have sixth problem. A hall, again, it is having 30 meter long and 12 meter wide is to be illuminated. And illumination required is 50 meter candles. There are 5 types of lamps having lumens output as given below are available. So they have given one table. So you can see here. So this is the table they have given, and they are going to use 5 different types of lamps. So they have 5 different type of lamps, and they will see in the further problem. So they have 5 different lamps, and each is having different wattages, and the different lumens is also given out here. Next, in this problem, taking a depreciation factor of 1.3, utilization coefficient of 0.5, calculate the number of lamps needed in each case to produce required illumination. So they have told you that how many numbers of lamps are actually required. So they have given 5 different type of lamps, and in the 5 different type of lamps, you have to choose one lamp, and in that lamp, how many numbers of lamps are required to produce uniform illumination. So out of above 5 types of lamps, select most suitable type and design a suitable scheme and make a standard ratio of lamp. So here they have told you that they have 5 different type of lamp. In that 5 different type of lamp, you have to choose one type of lamp which is required to produce uniform illumination. So you can see here, calculate the space to height ratio and the mounting height ratio you can assume. So usually the length of this is 30 meter and 12 meter is the width direction. And illumination is given. Depreciation factor, utilization factor is also given. Again, gross lumens can be calculated A into E into DF divided by UF, so that you'll get 46,800 lumens. Next, so we will calculate one by one. If 100 lamps are used, then how many numbers of lamps are actually required? Because how do you calculate the number of lamps? Because you have the actual lumens. The lumens which required is nothing but 46,800 lumens. So this is the total lumens which is actually needed. You can use any type of lamp and you have to get the 46,800 lumens. But all lamps, like how many number of lamps, which is depend again on the wattage, and again depend on the wattage. So whatever may be the lamp you can use, and you have to produce this 46,800 lumens, but you have to choose one type of lamp which has to produce good illumination, um, and it should produce the suitable scheme. Okay, so therefore, how do you calculate the number of lamps? So which is nothing but flux divided by again that is the total number of lumens divided by lumens. So you can see here, for 100-watt lamps, they have given how many lumens it is actually generating. So therefore, 46,800 divided by 1615 is nothing but 29 lamps. So if you use 100-watt lamp, then you have to use 29 lamps. So you can see here, 29 lamps are required. which is having 100 watt lamp, 100 watt rating, 100 watt rating, and it will produce, like if you combine all these 29 lamps, you will get 46,800 lumens, and each lamp is producing 615 lumens. Okay. So next again we will go for 200 lamp. If 200 watt lamps are used, then how many number of lumens are required? It is nothing but 46,800 divided by 3,650. So therefore we will get 13 lamps. If 300 watt lamps are used, then again 46,800 divided by 4,700, you'll get 10 lamps. Again, if 500 lamps are required, then again 46,800 by 9,950, you'll get 5 lamps. Then if 1000 wattage lamp is used, then you'll get 2 lamps. So like this, by using this table, you have calculated how many number of lamps are required by using such type of lamps, like by using such wattage type of lamps. So here we have a statement that, so you have to be very careful, because this statement is very important, because the lamps of lower wattage require more number of fittings. So here only you have understood that for 100 wattage lamp, how many number of lamps are required? Like such lamps, how many such lamps are required? 29 lamps are required. So if wattage is less, that is if lower wattage is there, then it actually requires more number of fittings or more number of lamps. So for each lamp you have to give separate fitting, and also therefore it increases the cost as well. So if lamp of higher wattage can be used, okay, but what is the problem is, if you use higher wattage lamp, then you can use only a few number of lamps, but it will give space to height ratio much more than the desirable. Then here what happened? Actually, the space to height ratio what we are taking, so this space to height ratio will be larger. It usually comes around 1, but if you use 1000 lamps, then how many such lamps are required? Only 2 lamps. Then actually the spacing will increase, and it won't produce the good type of illumination. So therefore, this is also not desirable. So therefore, so most suitable type of lamp is 300 watt lamp. You can use 200 watt lamp also, but you can use 300 wattage lamp, because it requires only 10 lamps, and it is actually the convenient type of lamp. So among 100 watt, 200 watt, 300 watt, 500 watt, 1000 watt, we have chosen 300 watt because it is actually the good type of lamp, and it also requires little lesser number, and here the space to height ratio is also reduced, and the cost can also be reduced over here. So then if you use 10 lamps, then how do you divide this? Usually we will go in this way, that is 5 and 5, that is 5 in rows, and 2 in, that is 2 rows, and there will be a 5 columns. Like that you can divide. So now you got to know that there will be a 2 rows and there will be a 5 columns. So then you can actually calculate axial spacing. It is nothing but total length of room divided by number of lamps in each row. So which is nothing but 30 by 5, we will get the distance, which is 6 meter. Again, transverse spacing can be calculated, total width divided by number of rows, 12 by 2, it is again 6 meter. So they have also told that you assume any mounting height, and thereby you calculate space to height ratio. We have assumed that let the mounting height be 5 meter. It is usually 3 meter, 4 meter, 5 meter. You can assume any of these three value. In this problem, for my purpose, I am assumed that it is 5 meter. So therefore, space to height ratio is nothing but axial spacing divided by mounting height. So therefore 6 by 5, which is nothing but 1.2. You can see here it will come around space to height, that is one unity. Okay. So like this you have to calculate. Next we will look on to the disposition of lamp. So you can see here we have used 5 lamps in each row. There are 2 rows and 5 columns. And distance between each lamp in horizontal direction is 6 meter. Again in vertical direction also 6 meter. Again, how do you calculate this 3 meter and 3 meter? So there are 4 times 6 meter is there. So 6 into 4, you'll get 24 meter. Again, 6 meter is left out. So therefore, 6 by 2, you'll get 3 meter, 3 meter. So that is nothing but the distance of lamp from the lamp, distance of lamp from the wall. Again, you can calculate same way, that is distance of lamp from the ceiling also. Next, this completes the problems on elimination. So these five problems what I solved here. So these are very important, and you have to be thorough with this. So usually, they will vary the certain values in this, and they'll ask you in the exam. So therefore, this is very important, and you have to be thorough with this. And problems on floodlighting, it has not been asked in any exams, but also you have to be thorough on this. So that is the front of a building which is having 50-meter length and 16-meter width is illuminated by 16,000 watt lamps. As I told you, floodlighting is nothing but what? It is used to flood the larger area, or it is usually used in it is usually used in lightning the monuments, ancient buildings, and also in the like stadium and all the large space. So therefore, here the building is having 50-meter length and 16-meter tall. Okay, is to be illuminated by 16,000 watt lamps. So to illuminate that lamp uniformly, you need 16 lamps, and each is having 1,000 watt. Are arranged so that uniform illumination on surface is obtained. If you use like this, you will get the uniform illumination. So assume luminous efficiency is 17.4 lumens per watt and coefficient of utilization as zero point 0.4. Determine the illumination on the surface. So how do you go with this? First of all, you list out the data and calculate the area. Then total lumens given out by the 16 lamps is nothing but what? How do you calculate this? So this phi is nothing but how many number of lamps are there, and wattage of each lamp into luminous efficiency will give you how many number of lamps are actually required. So lumens per watt, watt will get cancelled, then you will get the answer in lumens. So therefore, you have to multiply number of lamps and its wattage into luminous efficiency. So 16 into 1000 into 17.4, you'll get the lumens as 2,78,400 lumens. So this is the lumens which is given out by the 16 lamp. But total lumens reaching on surface to be floodlighted. So how do you calculate this? So this can be calculated by this formula, that is um, phi into df phi into df into wf divided by uf, correct? Or actually this is phi into uf divided by df into wf. So like this you have to calculate. So this is with respect to surface, so therefore you have to divide depreciation factor and waste factor and multiply utilization factor. This is with respect to surface. With respect to light, then you have to multiply. With respect to surface, you have to divide. With respect to light, you have to multiply. Next, substitute the value. You'll get the value, which is nothing but 71,400 lumens. Next, illumination only we need to calculate. Illumination is nothing but total lumens divided by area. So therefore, it is nothing but 71,400 divided by 800, which is nothing but 89.25 lumens per meter square. So next problem is that actually I have some doubt with the next problem. So I will solve that problem when I'm taking the regular class. Okay, thank you students. If you have any doubt with this, you can ask me anytime. Hope all of you have understood this. If you not at all understood, you can ask me at any point of time. Watch this video 2 to 3 times, so therefore you'll get better idea. Thank you again.